All right, in this example, we're told, or we're told to suppose, that we want to retire in 45 years. How much should we deposit at the end of each month into an IRA that pays 6.5% compounded monthly in order to have $2 million in 45 years? Whew. Okay, well, first things first, the amount of time going by is 45, so t equals 45. The interest rate is 6.5%. And it says it's compounded monthly, so the number of compounds per year is 12. And the amount we want to wind up with is $2 million. So A is $2 million. And we're told to round up to the nearest dollar. So if we want to have the payments we should make, P equals every month, in order to get a certain amount at a certain rate compounded a certain number of times, the formula is as follows. The payment is the amount times the rate divided by the number of compounds, all of that over, now I'm using brackets here because there's going to be parentheses inside parentheses and it helps keep track of everything. So that's going to be bracket and then parenthesis 1 plus the rate divided by the number of compounds raised to the number of compounds times time minus 1. And that's your formula. So, it's a bit of a behemoth, but we have everything we need, so let's set it up. The amount we want is $2 million. And whenever I use a rate in one of these formulas, it can't be a percentage, it's got to be a decimal. So I'll take this decimal and take them 2 hops to the left. Doop, doop. So we get 0.065. So 0.065 divided by a number of compounds is 12, all over 1 plus 0.065 over 12 raised to the 12 times 45 minus 1 inside a bracket. Okay. Whew. Okay, so I want to make extra sure I put this in carefully and that the calculator does not get confused. So first things first, I have more than one number. I have operations going on in my exponent, so I'm going to throw parentheses around this. And I probably don't need them, but again, I'm really nervous about everything working here, so I'm going to put parentheses around the entire top as well. So let's put this in the calculator. So first things first, open parentheses. I'm going to type in the 2 million. And then I have more parentheses right here. So parentheses, 0.065 divided by 12. Close these parentheses and close the paranoia parenthesis here. Divided by, all right, double parentheses again. So 1, 2. And we're going to put in a 1 plus 0.065 divided by 12. I'm going to close this parenthesis. Raised to the paranoia parenthesis, 12 times 45, close the pink parenthesis there, and if you've got one of the new calculators, you need to push the arrow key to the right to make the cursor come down, so I'll do that, minus 1, and close that parenthesis. Whew, okay, so if I hit enter, and we're told to round this up to the nearest dollar, so what I'm actually getting is 619.48 blah blah blah. So 619, really actually they said to round up, meaning don't round by traditional methods. Don't look at this and say if it's 5 or bigger, add 1 or whatever. No, just round up. So all the decimal numbers get chopped off and we get $620 as the monthly payments we should make. And again, the reason they always say to round up when you're doing this I'm saving money type stuff is because you want to be absolutely sure that you put the amount you need to put in there so that you get the amount you're looking for at the end of that time. So, if you make $620 payments every month for 45 years at a 6.5% interest rate, compounded monthly, you should have at least $2 million in that account by the end of that time. And so, there you go. That is this example.